Hello everyone, I hope you're crystal clear with the topics that we've done so far, and today we're going to cover one last data structure, and that will bring the end of this particular series. And the data structure today that we're going to cover is sets. Okay, so what are sets? Sets are a data structure that store unique elements. You cannot have same element twice in set, and they are unordered, no particular order. Now I know I said that you cannot, I last told you that dictionaries are also unordered and that you cannot sort a dictionary, but then we changed that. But nevertheless, sets are still unordered and they are mutable. What does mutable mean? We've already discussed this in tuples, that you can change the data that is present in a set. Okay, so sets have a couple of functions that we're going to test on the Jupyter notebook. Okay, so let's see. So how do you define a set? Let me define a set S, and set of, let's say, a string geeks for geeks, and if I print S, so you see all the values, all the different alphabets of this particular string, but only once. No alphabet is repeated. Okay, and the order is basically unordered. Sets automatically store information which are in a manner which is efficient in memory management. Okay, so if you want to convert a list into a set, you pass a list 1 2 3 4, and if you print S, it gives 1 2 3 4. Now what if I put duplicate elements in the list, like I put 4 n number of times? It will still be stored only once. Okay, cool. Now you can also, let me just keep this in this manner only. You can also define a set using curly brackets. So now curly brackets can be used to define a dictionary, and they can also be used to define a set. Now if I pass this as a set, multiple values of 4 and then multiple values of 5 and 6, and if I again print S, okay, invalid syntax, sorry about that. And now you get 1 2 3 4 5 6, all the elements just once. Okay, so now let us cover some functions. You have to add an element to a set. How do you do that? So you define an empty set, and then you use the add function. So s dot add, let's say 9, and if I print S, it has 9 in it. If I also add, let's say 8, then I get 8 and 9 in the set. Now if I want to add using a for loop, so for I in range, let's say 1 2 5, and s dot add I, so the elements 1 2 3 4 are added. For loop doesn't include the last element. We've been over this. Okay, now what if we do not want to use a for loop, but I still want to add multiple elements to this set? Now I'll use the update function. Okay, so same empty set, and then s dot update, I'll pass a list that has 1 2 3 4, and now let me just shift this to a new cell, and I print S. Okay, so if I print S, then as you can see, we have the set with 1 2 3 4. Now what if in this list I put in multiple elements? Right, I can put multiple elements here. It will automatically manage that, so that there is only one element present in the set. I mean one element, not one element in the set, but like one unique element in the set. Okay, now if you want to remove an element, then what to do? Then we have, let me just, we'll take this S set only, and we'll use the remove function. So s dot remove 4, and if I print S, so it has 1 2 3. Here it has 1 2 3 4. I removed the element 4, and now I have 1 2 3. Okay, now moving on. let us find an union and intersection of two sets. Okay, so we have a set 1 2 3 4 and we have another set S. Let's name this S1 and S2, and this is 3 4 5 6. So if I have to print union of S1 with S2, so I'll use the union function, and this is the union of S2. Now another method of getting a union is this operator, which is supposedly the straight line, and now also you get the union. Okay, now if I am to find the intersection, I'll just keep it there. So this, or print S1 dot union S2. Okay, same results in both of them. Now if I want to find the intersection of these two sets, so I'll print S1 dot intersection S2, and the only common elements between them is 3 and 4. Okay, another method of getting the same result is the AND operator. So S1 and S2 also gives the intersection of two different sets. Right, now if I want the difference of two sets, let me just write here intersection, and let me write here difference of two sets. So like you let me just show it to you graphically what difference of set means. So now this is set A and this is set B. So now if I tell you to shade the region of A minus B, then A minus B would be this region of A minus the region of B, that is the common region. Okay, so this would be our A minus B, right? So if I have to find out A minus B, same sets, and S1 minus S2, and I get 1 2, because 3 and 4 are part of B or S2 set as well, so you get 1 comma 2. And you can also find this by S1 dot difference S2. Okay, same results in both manners. And if I have a set S 1 2 3 4, if I type in S dot clear, then if I now print S, now S will be an empty set. So clear function clears the set of all the elements it has. Okay, and if I want to print every element in this set, so for I in S, print S, sorry, not print S, print I, prints all the element. If I want to find out if an element is present or not in the set, so I'll write if 2 in S, print present, it prints present. Now let's write an else statement, else print not present. Now if I want to find out if 10 is present in this set, which is very visibly not present, so if 10 in S, not present. So as you can see, 10 is not present in this set, and it gives us the desired result. Now one last operator we'll try to cover here, that is the XOR operator. So if this exponential sign is the XOR operator, so it gives elements that are present in only one of the either sets. Let's see how it works. So 1 2 5 6, these are the elements this XOR operator gives. Let's try to find out what it exactly means. So now I have two sets, set A and set B, right? So if I have to find out A XOR B, so if I have to shade the region, that is A XOR B, so it will be elements that are present in only one set, right? that are not common, that are unique to the set that they are present in. Okay, so as you can see here also, 1 2 is present only in S1, 3 4 is the common value, and 5 6 is also present in S2. So S1 XOR X2 gives us 1 2 5 6. Okay, that's pretty much all that you need to know in sets. And sets are a very important data structure, so you can go through the video again. If you have any doubts, please post them in the comments and I'll make sure to reply to all of them. Thank you.